Why is this unlinked? This should be to Gamedev. And we are going to rename it Gamedev. Oh. Oh, you're not a bot. Why is this not letting me rename? Say potato. Bruh. Alright, where was I? Schwonk. Udemy.com. Instance versus default. Potatoes. There he is. Potato. My man, showing up. Potato. Sorry, I just get a lot of bots. Not that it'd be bad if you were a bot.
Hey, welcome back.
But I would probably interact with you less if I knew you were a bot. Shook Sky's a real one. Now we know. Pass the potato test. You want me to call you Hashtag? Hashtag. You have tech? Hashtag.
In this video, we're going to make the distinction between instances of a particular blueprint class versus the default blueprint, which is
You say what? Potato. Yeah, man. Yeah, for whatever reason, sometimes bots have a tough time following instructions. So, I mean, has teach.
the blueprint that applies to all instances. We're also going to see how we can assign read or write access for a particular C++ variable in blueprints. So let's get started. We're now ready to start exposing some of our components to Blueprint. So here we have our components, and we've seen that if we click...
Okay, we are now making a game, has teach. Has. Hus. I want to open up Pong Tank. BP Pond Tank. Where is BP Pond Tank? Let's go. This.
Click on each one of them.
And we want a blueprint editor, please. There we go.
Our details panel is completely empty, so we need to learn how we can expose certain properties to Blueprint, and we do that by the use of our uProperty macro. So let's jump back into...
Need to open VS Code, Visual Studio, Visual Studio. Code.
VS Code and take a look at the uProperty macro. This is a special macro. It's unique to Unreal Engine, and it's got this set of parentheses because it can take input parameters. Now, in order to show how to
What do I want? Base pawn? Yeah, I think base pawn. That's what's up.
expose things in certain ways, we're just going to create a couple of throwaway variables that we can just delete when we're done. We're just going to...
True, would be a lot more interesting. Trying to grow naturally, you know what I mean? Post some videos, sticking to a schedule. I just changed my schedule, actually. I need to
see
update
how
that.
this exposure thing works. So we can make some integers. Let's make an int 32, and I'm going to call this int 32 visible anywhere int. And just right here, I'm going to initialize this to a value, say 12. Now, in order to expose this to the reflection system, we're going to need a uProperty macro. Now, this is just a plain integer variable. It's not a component like these, so it's not going to show up in the Components tab. Remember, here in the blueprint, we have this Components section, and any components show up here, but any regular variables, those are going to show up if we click on BP Pawn Tank self, for example. This is where we see all the other variables that are not components. So back in VS Code, let's decide how we're going to expose visible anywhere int. Well, I'm going to introduce you to some uProperty keywords. These are options that can go into the parentheses for the uProperty macro. For this one, we're going to add visible anywhere. Now let's go ahead and compile this.
Visible.
Okay, so we've compiled. Let's jump back into the editor. And here in BP
Excuse me,
Pawn
stop.
Tank, I have the BP Pawn Tank self selected here. And I can search in the details panel.
All right, we're going to recompile. Gonna stop biting me. Lighting needs to be rebuilt. 7 unbuilt objects. Wow. Wowza. Don't. Kona, you paw me? Hey, keeping me at arm's distance, but I want to give you kisses. Mwah. 1, 2, 3. Woo! 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 Kiss. Don't paw me. There you go. Yeah, I'm not really looking for oh shit. God. Oh no, do I have to reset OBS now? Kona. Has teach expert. And it's my is this still working or what? Can you see me? Can you hear me? What you think? What you think? I would really love to not have to reset this. Yeah, the vid's not moving. Bummer. Scene 2. Let's add video capture device. Okay. Very annoying. All right. Try to unplug this and reset it perchance. So annoying, Kona. Why do you have to do that? I guess it's on me. It's not your fault, Kona. It's not your fault. It's not your fault. Video. Camera. All right, so it's not detecting the camera now, which is an issue. There it is, USB camera. There we go. All right, camera's working. Logi. Video capture. Logi. Okay. Bang. All right, this is working now. Unfortunately, need to add this. Disable that. Okay. This doesn't need to be that big. Scene 1. We will disable this and I'm getting kind of hungry. Cancel. Doesn't need to be that big. There we go. Okay, I think we're back. Excellent. Shook Sky, I probably am not looking for any help at this moment. But appreciate you reaching out.
For visible, and here is my visible anywhere int. Notice the blueprint places spaces.
Okay, wait, so did I compile? Yes, I did.
In between each of the words.
And BP spawn, BP pawn tank on self, visible anywhere int. There we go.
Thanks to the way we've named this with camel case. And check this out. We can see that it has a value of 12, and it's grayed out. We can't actually edit this at all. So that's what visible anywhere means. It means it's visible, but we cannot edit this property. Okay, so let's go ahead and create another int 32. I'm going to call this one edit anywhere int. And for this, I'll just give it a value, say 22. And this one will get its own uProperty macro. And instead of visible anywhere, I'm going to give this one the keyword edit anywhere. Let's go ahead and compile this. And back here in the editor, I'm going to search instead for edit anywhere. And here is my edit anywhere int. And you can see it has the value 22, only it's not grayed out anymore. I can select it. I can change it. It's editable. That's what edit anywhere means. It means we can change it. So even though we're initializing it to 22 in C++, we can overwrite that value here in the blueprint and give it a new value. So now you've learned about visible anywhere and edit anywhere. But there are more keywords than these two. For example, let's create a new int 32 and call this one visible instance only int and initialize this to 11. Now it's going to get its uProperty macro, and the keyword I'll give to this one is visible instance only. Let's compile this. And back here in the details panel in the blueprint, I'm going to search for visible. Now notice we can see visible anywhere int, but where is our new variable? We called it visible instance only int. See, visible instance only int. Well, we can't see it here, but check this out. I'm going to take our BP pawn tank and drag one of these out into the world here. And we can see in the world outliner, suddenly we have a BP pawn tank here in the world. Now with this selected, I can come down here into the details panel and search for visible. Now check this out. Now we can see our visible anywhere int and our visible instance only int. So how come we can see it here, but we cannot see it when we're looking at the actual blueprint?
Build failed. It's visible instance only. Was that what it's called? $69. Edit anywhere into visible.
Self. Well, there's a distinction I want to make. You see, when we have our blueprint here in the content browser, we can double click it, we can open it up, and
Build failed.
save properties. What we're looking at here is the default blueprint. This contains all of the default information for the blueprint. But as soon as I drag one out into the level, we now have something called an instance. So this particular BP pawn tank that exists in the world.
Yeah, no, I get you, buddy. Has teach, just not, it's not for me, dog.
Is an instance of BP pawn tank. In fact, we can drag out multiple instances, and each of these that exist in the world are instances of BP pawn tank. This is different than the default blueprint. So here's a little graph for you to refer to, and we're going to be filling this graph.
Visible instance only. This should be a property.
Out more as we learn more specifiers. So far, we've only seen visible anywhere, which you'll see is under both the defaults and the instance columns, and it's in the row titled read only. So you can see from this graph that a visible anywhere uProperty will only be visible, it won't be editable, but it will be visible on both defaults and the instance, whereas visible instance only has read-only access, but only on the instance. You can't actually see it on the default blueprint. And then we learned about edit anywhere, which allows us to actually edit that uProperty on defaults and the instance, so that's why it exists in both the defaults and the instance column. So as a challenge, I would like you to add a variable to the base pawn class. Now put this in the public section, and what you're going to do is decide what type of variable you'd like to add. It can be anything, but make it a basic type, like an integer or a float. You could even make it an f vector or an f string if you want to. Just initialize it with a default value like our other int32s, And this could be any variable you want. You can make a speed variable or a stamina variable. You've got some freedom here. Now, once you've created this variable, decide which access level you want for this, and then give it a uProperty macro and add the correct specifier. Now, decide whether you want this to be visible only on the instance or on the defaults, or if you want it to be visible anywhere or edit anywhere. Use one of the specifiers we've learned so far and give this variable the correct specifier. Go ahead and pause the video and make this variable now.
I ain't pausing.
All right, so I'm going to go ahead and make a variable. Now, it's okay if you made something completely different. This is just
Visible instance only. V-I-S-I-B-L-E. V-I-S. This should compile. In instance. Why isn't this compiling? Unknown specifier visible instance only. Again, visible instance only. Not working.
for practice. I'm going to make a float, and I'm going to call this speed, and I'll initialize speed to, say, 400.f. And I think I'd like this speed variable to be editable both on the instance and on the default. So I'm going to give this a uProperty macro and make this edit anywhere. So I'm going to go ahead and compile.
Does not comment it out. Ouchie. Burp.
This, and back in the editor, I can select one of my base pawn tank instances, and here in the details panel, I can see my speed variable, and I can of course edit it here. And if I open pawn tank, here's my speed variable. It's set to 400.
I'm there, buddy. I'm just not gonna. Yeah, I'm not interested in.
And it's editable.
I don't
So
have
in summary,
pain
we've
for
learned
anything.
the difference between an instance versus the default of a particular blueprint class. We also learned a few uProperty specifiers, such as visible anywhere, visible instance only, and edit anywhere. In the next video, we'll continue learning how to control access to C++ variables in Blueprint using these uProperty specifiers. I'll see you soon.
Thank.
Hey, welcome back. In the last video, we learned a few uProperty specifiers that allow us to expose our C++ variables in certain ways to the details panel in the blueprints. In this video, we're going to learn some more.
This should be on here. Wait, speed. There we go.
Specifiers that allow us to have more control over access to those variables in the details panel. We're also going to talk about how we can allow read or write access in the actual event graph for a particular C++ variable. So let's dive right in. Okay, so I'm back here in VS Code, and here are the variables we created in the last video. Now here is my speed variable.
I don't understand why visible instance only is on. V-I-S-I-B-L-E. Visible. Am I spelling that wrong? V-I-S-I. V-I-S-I. Oh, visibile. Durr.
This was for the challenge. You probably created a different variable.
Challenge!
Fine. So keep that variable there. We're going to do some more things with it in this video. Now we've learned that we can make a variable visible anywhere. And when we say anywhere, we mean on the details panel, either on an instance or on the default blueprint. We saw that we can also make it edit anywhere. And when we use visible instance only, it's only visible on an instance. You can't even see it on the default blueprint. And in any case, you can't edit it because it's grayed out. So this allows us to make our variable visible only on the instance. But what if we'd like it to be visible only on the default blueprint? Well, there's a specifier for that too. Let's make another int32. And let's call this visible defaults only int. And we can initialize this to a value. I'm going to give it 5. And we'll give this a uProperty as well. And the specifier for making this visible only on the defaults, you could probably guess what it is. It's visible defaults only. So I'm going to compile this. And back here in the editor, I'm going to open up bppontank again. And with bppontank self-selected, all of our variables are up here at the top, so I'm not going to search for it. But here's our visible defaults only int, and it's got the value 5. And of course, it's grayed out. Now, as the name suggests, it's visible only on the default. So if I go in the world and select one of the instances of bppontank here, there is no visible defaults only int. It's not visible on the instance, only on the default.
Why would
So
you want to do that?
Now let's go back into VS Code, And we have a few more specifiers to learn about. Now we've seen that we can edit anywhere, and that with our visible specifiers, we can choose instance only or defaults only. So as you've probably guessed, we can edit on only the instance or only the defaults if we choose. So let's make a couple more int32s. I'm going to make one called edit defaults only int and initialize that to a value, say 9, and then another int 32 called edit instance only int. And I'll give this a value of 14. So we want edit defaults only int to be editable only on the defaults, and edit instance only int to be editable only on the instance. Now, the names of these specifiers are pretty consistent, so I'd like you to just guess what the specifiers would be for these two access levels. Go ahead and just do a quick little mini challenge.
Edit defaults
See if
only.
you're right.
Edit
Okay,
instance
so these are going to be
only.
U properties, and edit defaults only int is going to get, you probably guessed it, edit defaults only. And for edit instance only int, I'll give this a U property macro, and this will be edit instance only. So it's pretty intuitive. Let's go ahead and compile these. And back here in the editor with bp-pontank open, here's our edit defaults only int. We don't see edit instance only int. We didn't expect to. It's set to 9 here. We can change it. And if we go into the world with one of our instances selected, we can see edit instance only int. And of course, that's editable as well. So we've now added 3 new specifiers to our graph here. We have visible defaults only, which is in only the defaults column and in the read-only row. And then we have edit defaults only and edit instance only in their respective rows. So we're filling up this graph pretty quickly, but you'll notice that there are a couple of spaces empty over there to the right in the event graph column. So let's talk about these for a minute. Now I'm here in bp-pontank, and we have all of these variables that we've exposed to the details panels. Depending on their specifier, you can see them here or on an instance. But what if I right-click here in the event graph? The event graph is another place where we can access variables and potentially change them. So if I type edit anywhere, I do not see the edit anywhere int. It's not exposed to the event graph. We don't have access to that. There is another specifier that allows us to expose things here in the event graph, and that can work in conjunction with these specifiers that control the details panel accessibility. And I'd like to expose one of these variables to the event graph. Now I could choose any one of these, but I'm going to choose this visible anywhere int. Now the uProperty macro can take multiple inputs. So we have visible anywhere, we can still have that. I'm going to place a comma, and I'd like to add another specifier that will give this visible anywhere int exposure to the event graph. So what I'm going to use is blueprint read write. Blueprint read write has to do with the event graph. It has nothing to do with control over the details panel. That's what this visible anywhere is for. So blueprint read write does as the name suggests, read access and write access. So let's see how that looks. Let's compile this. And I'm back here in the editor, in the event graph. If I right click and type visible anywhere, we'll see 2 different options, get visible anywhere int and set visible anywhere int.
Interesting.
Select get visible anywhere int
Cool.
node, and this is just like any other blueprint node. It represents that C++ variable. And if we drag off of this, we can access that value to do something with it. Now I'm going to scroll out and you'll see that we have these grayed out nodes, actor begin overlap and event tick. And begin play is called at the beginning of the game, as you know, so we can do something here. I'd like to use a print string node, and if I drag off and type print string, then here it is. It's a blueprint function node, and it takes a input called inString. Now, if I hover over it, it says inString, and then string right below that. That's the type that this node accepts as an input parameter, and we know that our visible anywhere int is an int32, not a string. But if you click from the output of this node and drag and stick it right here in the input before you release the left mouse button, you see a pop-up that says convert integer to string. And if you release, then you get this handy conversion node that converts from an integer to the string type, which is very handy for us because we don't have to figure out how to convert an integer to a string. It's just automatic for us. Now, if I hit play, we'll see the value 12 printed 3 times, and it only lasts for a few seconds. That's the behavior of print string. Now, the reason we see it 3 times is because I have 3 different instances of bp-pontank here in the world. Depending on how many you've dragged into the world, you'll see that many, because for each of these individual instances, begin play is getting called at the beginning of the game. So just to avoid confusion, I'm going to just delete my other 2 and just leave a single instance of bp-pontank here in the world. So I have only 1, and if I go and hit play again, then I see 12 printed to the screen only once. So that is read access to visible anywhere int. But we saw that we also have write access. That means we can set its value from here in the event graph. So if I right click and type visible anywhere int again, then I can select set visible anywhere int, and I have a setter node, which takes an input. We can pass in the value from some other node, or we can take this little text box and hard code a value, say 66. And now as soon as the flow of execution from begin play reaches this node, then the setter node is going to write to visible anywhere int. It's going to set its value to 66. And of course we can print this out again. So I'm going to use print string. And for the value passed into print string, I'd like the value of visible anywhere int. Now I can do this one of 2 ways. The setter has a return node. So after it's set the value, then it returns that value and we can use it. So we can plug it straight in to print string. The other way is to simply right click and get visible anywhere int, use that get node, and we can hook up the value from this node right into print string. That would do the exact same thing. So I don't need that. I'm going to delete that node. And now what I'm expecting to see when I play the game is to first print out the value of visible anywhere int, which starts off at 12. And then after setting its value to 66, I should see the value 66 printed out to the screen. So let's hit play, and we see 12 and 66. Now they look like they're in reversed order. That's because print string adds newer messages on top. So that is normal behavior. Okay, great. So we've seen that we can make a variable blueprint read write. Now we can also control whether or not we can set this from the event graph. So let's expose another variable so that we can get it from blueprints but not set it. Here's edit anywhere int. I'm going to add a comma and add a specifier to this. Now, in order to access it in the event graph but not be able to set it or write to it, the specifier is blueprint read only. So edit anywhere int is now blueprint read only. It's still editable in the details panel, both in the default and on instances, but in the event graph, it's read only.
I'm hungry.
So let's go ahead and compile this. And back here in the editor, I'm going to right click in the event graph and type edit anywhere, and check it out. We have get edit anywhere int, but we do not have a set edit anywhere int because it's blueprint read only. We cannot write to it. So I'm going to select it. Here's edit anywhere int, and if I wanted to, I could use a print string node to see its value. No need to do that. We already know how to do that. I'm just demonstrating that we cannot write to this variable. Okay, so I'm going to go ahead and highlight these nodes and delete them. So our graph is now filled out. We've learned that we can make our variables visible only on the defaults, and we can make them editable only on the defaults or only on the instance. So we really have full control from the C++ side.
Full
Now,
control.
We also saw that we can expose these variables to the event graph and make them read only or read write using these blueprint read only, blueprint read write specifiers. So now you have a challenge. In the last lecture, we created a variable. I made a float and called it speed. Now you're going to take that variable you created in the last section and control its access in the event graph. So expose it to the event graph using one of the new specifiers you've learned. And then you're going to test out the read write access for this. Use a print string node so that you can see its value, and if you change it, prove to yourself that you've changed it. So if you make your variable blueprint read write, try changing it with a set node and then using a print string node to see its value using event begin play. If you made it blueprint read only, then you can simply get the value and print its value using print string. So add the correct specifier to your custom variable and use print string to test out access in the event graph. Pause the video and give this a try.
Paused. Video equals paused. Execute. Burp. Speed. Get speed. Let's do print string. And then I think if we do set speed. Yeah.
Okay, so I'm going to scroll down to my speed variable here, and my speed variable is edit anywhere, and I'd like it to be blueprint read write so I can change it from within the event graph. So I'm going to add blueprint read write and simply compile. So back in BP Pond Tank, if I type speed, now I see the getter and setter for this. So I'm going to use set speed. I'm going to set its value from begin play. So let's hook this up, and for the value, I'm going to enter 900. And from the
900.
set node, if I drag off, I can type print string. Now I'm going to click and drag off of the output node, hook it up to string. So if I hit play, there's 900. Notice it says 900.0. That's because this is a float.
float.
It's giving me the courtesy of showing that first decimal point. So that's kind of a nice built-in feature here. It's showing me one digit to the right of the decimal point for my speed variable. So in summary, we learned some more specifiers for...
Hello, Shook Sky.
We learned visible defaults only, edit defaults only, and edit instance only. And we also learned how we can control read-write access in the event graph with blueprint read write and blueprint read only. The C++ programmer has a great deal of control over what gets exposed and what can be changed in the blueprint and where. We'll be using these throughout this section of the course, and you'll continue to use them throughout your career as an Unreal Engine developer. I'll see you in the next lecture.
Exposing the components. Let's expose them components. Where them components at? Not expose,
Hey,
need
welcome
to
back.
expose.
We're exposing variables to blueprints, and now we'd like to talk about exposing our components. This will allow us to set some of the properties, such as the meshes, on our static mesh components, as well as positioning our capsule and projectile spawn point. Now, we're back here in VS Code, and we have all of our test variables. And before we start going and exposing our private component variables, there's just a couple more uProperty-specific things we need to learn about. For one, all of our test variables are in the public section, and a couple of our variables here are exposed to the event graph, allowing read access and write access, and these are not allowed in the private section. For example, if I take our visible anywhere int and edit anywhere int and cut these and paste them down here in the private section along with our components, here's what happens when we attempt to compile. Here we see in our terminal a couple of errors. We see blueprint read write should not be used on private members, and it says the same thing about blueprint read only. So what if we want read and write access in the event graph on private members? Well, there's a way to get around this. We can still have access to private variables in the event graph. We have to add another input to the uProperty macro, and that input looks like this. We say meta equals, parentheses, allow private access equals, and in quotes,
Jesus.
true. Now, this looks pretty weird. It's sort of a nightmare of syntax, but this is what it looks like. uProperty macros
Smoking
allow for
Cura
metadata,
Teats
and metadata is just a fancy
J86P. Your
word for
chat's so
data
quiet.
that
I can
gives
hear your
information
viewers
about other data.
snoring.
So we
Wake
have
them
this
up
meta
with
equals, and if we use allow
dogehype.com.
private access
No,
equals
I
true,
will not do
then we
that.
can expose these variables to the event graph even though they're
Sleep,
private.
chat,
Now, if
sleep.
you're a stickler and
Don't
you
let
think
these
giving
bots
private
get
access
to
to a
you.
variable is a very good idea, well, you don't have to do this. This is just another tool in your toolbox that allows us to expose private variables to Blueprint. And on the C++ side, these are still private. You still can't access these from other classes, so you have that encapsulation on the C++ side. This just gives you the ability to get these in blueprints and make changes to them. And really, in blueprints, it's kind of a different world. Typically, you're not going to expose things to blueprints that someone could go in and change and potentially break the game. But it's useful to know how to do this, so we're going to give this meta allow private access to both visible anywhere int and edit anywhere int. So let's compile this. And now we see we have a successful compile, even though we have blueprint read write and blueprint read only on variables in a private section. Now back here in bp-pon tank in the event graph, I can right click and type edit anywhere, and here we see get edit anywhere int. We still have access to it, and if I search for visible, I see visible anywhere int. We can get and set it. Now the last thing I'm going to show you that we can add to uProperties is a category. Notice here in the details panel, these variables we've added are under this category base pawn. This is the name of the class, and that's
Nice.
where they go by default. But notice that we also have other variables inherited by this class, and they're each in their own categories. Now we can create our own category for these exposed variables, and we do that by adding category equals, and in quotes, we can give this a category. So I'm going
Nice.
to call this super duper variables. Now I'm going to have a here because I placed this here in the uProperty macro as one of the inputs, and all of the inputs have to be separated by commas. I'm going to copy this and add it to the uProperty here for edit anywhere int as well. So now these should be in their own category called super duper variables. Let's compile, and back here in the editor, check this out. We have super duper variables, and our variables are here. And I can right click in the event graph, search for super, and check it out. We have super duper variables, and our variables are here. So this is a nice way to organize our variables and make them a little bit easier to find. So
Makes
I've added
sense.
a couple new things to our table here. We can give private access, we can take private variables and still expose them to the event graph with this meta specifier, and we can also give variables their own category to organize them in blueprints. So now that you know plenty of ways to control the access to our variables in Blueprint, you're going to fill out the uProperty for the components. Now decide their access levels. You're going to want visible anywhere for these, because edit anywhere is not something you want to give to your components. This means you can actually edit that pointer variable, and we don't want to change the pointer. It should always point to the object we constructed in the constructor. But you can also decide whether or not to give them read-write access in the event graph. Give them a category. This will allow us to keep our variables organized. Now, if you're going to give them blueprint read write or blueprint read only, you'll need to allow private access with that meta specifier because these are private variables. Now, once you've exposed the components to blueprints, then you can set some properties in the default blueprint. You can give the static mesh components their own static meshes, so set that up in both the pawn tank and in the turret blueprint, and position the capsule so it's roughly encompassing the volume of the meshes, and position the projectile spawn point. Place it at a point that would make sense for projectiles to spawn from. So pause the video and expose our components to blueprint. Okay, so here we are in our private section, and we'd like to expose these components. Now, first I'm going to give my capsule component visible anywhere. And I'm going to just decide to give this blueprint read only, so I can access the capsule comp variable in the event graph, but I cannot set it. Now, I'm going to give these the category, and for our components here, I'm just going to give it the category components. Now, because I'm using blueprint read only, I'm going to use meta allow private access equals true, so I'm going to put that right there.
Why?
And for the rest of my components, I'm happy with with these same uProperty specifiers.
I don't understand. No, we shouldn't be doing this, but why even make them private?
So I'm going to give them all the same specifiers. Now I'm going to compile this, and back here,
Compilation. Build failed. Base pawn 18. Category. Categorically? Oh, I didn't change my... People still think I'm playing Overwatch. Unacceptable. We're doing game development. Save. Okay, now I'm back here. Pew, pew, pew.
in the editor, I'm going to click on the viewport so I can actually see what I'm doing here.
Bond bank.
And I can select base mesh, and for the static mesh property, since we're in the pawn tank blueprint, I'm going to choose tank base.
Okay, interesting. Base mesh. I got this. Static mesh and tank base. Bang.
That's the base of the tank. Now I can select the turret mesh, and for its static mesh, I'm going to select tank turret, and now our tank blueprint actually looks like a tank. Now before I set the projectile spawn point, I'd like to adjust the capsule component so it's roughly encompassing the volume of the mesh. Now with the capsule component selected, we have these properties capsule half height and capsule radius. I'm going to scale the radius and the capsule half height just so that this is looking like approximately the correct shape. And I'm going to need to position my tank so that it's down at the bottom because our capsule component is the root component. We have to move all other components relative to the root. So I can select the base mesh and move it down. And to get it just right,
Oh my, FAO Schwartz. How did you do this? You were doing that pretty cool. You're strolling, baby. Smash. Slurp. Seventy-six, 76. 69.
I can angle my view like this, or I can come up here where it says perspective and select right. And I'm now
Oh, what? Viewport. Perspective. That is a perspective, y'all. Oh,
In orthographic mode. This places everything on a plane so I can move things and get them just
holy shit.
up here where it says perspective and select right, and I'm now in orthographic mode. This places everything on a plane so I can move things and get them just right. Now I'm going to turn off snapping so I can position this more precisely, and I think that's looking pretty good. Now I'm going to go back into
Uh,
perspective mode so I can see this and make sure everything looks good, and I'll select my capsule component and make sure the scale is just right.
did it not go down? Why are my hotkeys working? That looks pretty solid to me.
Now this may take a little bit of adjusting to get right, but with a few tweaks you can get it looking pretty good. So I'm satisfied with this. Next, I'd like to position the projectile spawn point. I'm going to
Holy shit, did he just do this and just go like... I love that. So, shit, go. Damn near perfect.
turn snapping back on and move it up just in front of the barrel here.
Projectile spawn point. Ah.
So this is looking pretty good. Now I'm going to go ahead and save this, and now it's time to set BP Pawn Turret. So here in BP Pawn Turret, I'm going to set the base mesh. So let's select the tower base, and I'm going to set turret mesh to tower. Turret. There we go. Now I'm going to scale up the capsule comp and
Base mesh, tower base, base turret is tower turret. There we go. And capsule comp, little height, little height action. We can't move that, can we? We can't. You want perspective, right?
move the base mesh down and just tweak this until I get it just right. And again, I can go into orthographic view and turn off snapping and get this positioned approximately the way I'd like it and go back into perspective. I think that looks pretty good. Now the last thing is the projectile spawn point.
Let's do front, please, and capsule. We will make your radius slightly larger. Big old radii here, bud. Height's gotta be decreased slightly. And we'll move this base. Turn snapping off, please. Thank you. Here we go, that's fine.
I'm going to turn snapping back on and position it right.
Projectile spawn. Right. These will go up, yeah.
Right here in front of the barrel, and I'll set the snapping increments to 5 just so I can position it right in the front there. Now make sure that the projectile spawn point is not too close to the barrel. We're going to be spawning projectiles from this point, and something that's tripped up some students is that their spawn point is too close to the barrel and there's a collision there, which can result in complications when spawning projectiles. Now this can be easily solved by making sure the spawn point is a good distance away from the barrel, and we'll polish this up at the very end of this section of the course. Okay, so the last thing I'm going to do is place a few of these in the world. I've already got a BP pawn tank here. I'm going to set that down on the ground.
What is this? Base pawn? Deleted.
And let's drag in a couple instances of BP pawn turret. I'm going to place one here and rotate it so it's facing outward. And then I'll go ahead and just place one at each corner here so that they can guard this central structure. And this is looking a little bit more like the finished product. There we go. And of course, if I wanted to, I could view this from the top. And in top orthographic mode, I can position these
Where the shindig is my... Oh, this is what we're at. Alt. Kinda crazy. Sure, this is fine with me.
more precisely, but of course this is a little bit less important. In a polished game, you're going to want everything to look just right. Okay, back to perspective mode. This is looking pretty awesome. So referring back to our section plan, we've created our tank, and our goal is for it to move throughout the world. So in the lectures to come, we're going to start learning how to do that. So in this lecture, we have exposed our components to blueprints, and we've set some properties in the blueprints for the tank and for the turret. Excellent progress. I'll see you in the next video. Hey, welcome back. Now we've already created a base pawn C++ class. In this video, we're going to derive from that class
Hey,
a
Green
new child
Coke.
class based on base
What
pawn.
it do?
So let's discuss why we'd want to do such a thing. So we have this base pawn class, and we know that we're going to have two different classes that derive from base pawn. We're going to have our tank, and we're going to have the tower. Now the base pawn contains meshes, a capsule, as well as a spawn point, and these are things that the tank and tower can both inherit. But the tank and tower are also going to have some functionality that differs from each other. For one, our tank is going to move around in the world, and it's also going to be controlled by the player, so it'll need to be configured to take input from the keyboard and mouse. The tower, on the other hand, is just going to sit there. It has no need for any input from...
Things are good here, dude. I'm just starting, well, actually not just starting, but I'm following a Udemy course. So this is just like a very basic, this is not any sort of creative yet. I'm literally just following a tutorial to kind of learn how to do this. And I'm going to see where it takes me.
the player, as its actions will all be controlled by code. So because the tank and tower will behave differently, we're going to make use of inheritance to create child classes of base pawn so we can inherit what they have in common and then add...
Dipping toes, yeah, for sure. I'm also getting a master's in game programming, but So I know some of this stuff. Like some of this is review, just in terms of like C++. But I have not actually used Unreal Engine, so it's good.
To each class those features that will be different. So we're back here in the editor, and I'm going to go into our C++ classes toontanks folder where we have our base pawn class. And this will be the class that we're deriving from. Now we can right click here and select create C++ class derived from base pawn. So let's choose that, and I'm going to allow it to stick this class in the same source/toontanks folder as base pawn. And for the name of this, I'm going to call it tank. So our tank class will be the class for our actual tank pawn that we're controlling and moving around in the world. So let's click create class. Okay, so we've compiled and VS Code has opened up with our new tank.
We have not compiled yet. Relax. Chillax, brother. Chillax. My machine takes forever. Yeah, Unreal is actually pretty nice. The advice I got from like my advisor, my professor, was do Unreal first because Unity is much easier to learn. So if you learn Unreal first, Unity will take much less time because Unreal's a little more complicated. So I was like, bet. Tank. You too, Green Coke. Have a blessed day.
.h file, and we also have tank.cpp. Now these are pretty bare, there's really nothing here, but even though we can't see them, we have inherited some things from the base pawn class. We do have those components that we've added to base pawn. Even though those are private variables, they still exist in this class. So now that we've created our tank class, let's talk about a couple of things the tank will need that the turret will not. Well, since we're going to be controlling the tank, we're going to need a way to focus on the tank as it's rolling around throughout the level. Now in this picture, this here is a camera component. Its C++ class is a camera component. And this red line here is called a spring arm component. And
I'll be lurking. Okay, lurk away, Green Coke. Lurk away.
Allows us to.
Let me I can hit that follow back, Green Coke, if you want. I don't know if you already followed me.
The pawn from the point of view of the camera, and if the camera and its spring arm are attached to the pawn in
some way,
they will follow the pawn around in the world. Now back here in the editor, if we go back to our pawns folder and open BP pawn tank,
there it is. There it is.
And then we can select the capsule comp and click add and
we love it.
Spring arm. This is a spring arm component. It looks like a red line. Now with our spring arm component selected.
Holy shnikes, I gotta re-go. What did you just say to me? Who's this guy? I was working with Sam forever, and now I'm on a different person.
Of the camera, and if the camera and its spring arm are attached to the pawn in some way, they will follow the pawn around in the world. Now back here in the editor, if we go back to our pawn
07.
Open BP pawn tank.
Okay, wait. I'm moving too quick here. I need to go back.
Class is use spring arm component. Adding these components to a pawn allows us to view the pawn from the point of view of the camera, and if the camera and its spring arm are attached to the pawn in some way, they will follow the pawn around in the world. Now back here in the editor, if we go back to our pawns folder and open
blueprints. Bones. You're a pawn.
BP pawn tank.
BP pawn tank. I already got it open. Bang.
We can click the viewport so we can see everything. And then we can select the capsule comp and click add and select spring arm. This is a spring arm component. It looks like a red line. Now with our spring arm component selected, we can add another component and choose camera. Now once we've added the camera attached to the spring arm, we have a way to see from the point of view of the camera once we actually start controlling the pawn. Now the spring arm is pretty useful. It has this target arm length, and if you adjust it, you'll see that the camera adjusts along with the spring arm. So
where are you?
This is a way to control how far away the camera is from the pawn. So these are definitely things that we want on our pawn class, but we're going to add them from the C++ side rather than just adding them here in the blueprint. So I'm going to delete those. So for your challenge,
freaking delete them. Let's add them and immediately delete them. Goodbye. See you later.
I'd like you to add some things to the tank class. For one, we need a spring arm component and a camera component. So create these variables and make them pointer.
Easy peasy. They should probably be private. Lily Boo, hey. What up, Lily Boo? Hey, that's a follow, Lily Boo. I'll sauce you one right back. How about that? You too, Lily Boo. Hope you have a fantastic day. Appreciate you stopping by. This looks complicated and smart. A little intimidating, but honestly, super simple. Like X's and O's, kind of just squares going into Circles going into squares, making things fit. But appreciate you stopping by. I'm making a video game, little Tomb Tankers. We gotta add some new private variables, all within this class structure. Oh, it's very exciting. Oh, it's very exciting. Look at me, private. You spring arm component spring arm gonna be supporting. Lily Boo, you're incredible. You are absolutely top notch, top of the class. Couldn't ask for anything more. Keep doing you. And you know what? I'll support you as well. And this is probably going to be...
Go ahead and make a public and a private section and put these variables in the private section. Now, we'll need these to be uProperties, so give them uProperty macros and fill in those
uProperty macros. We need the uProperty here, huh? uProperty. What are we making these? Edit anywhere? No, we want visible anywhere. Probably. uProperty. Support. We love support.
Macros with the appropriate specifiers based on what you've learned in the previous lectures. Now, once you've created these variables, create a constructor.
We actually need this in blueprint read only, I think. I don't know why we'd want to edit it. Then we also need meta. What? Category can be components. I don't know why we're allowing private variables to be. Hey, emoji, emote. We eating.
Put this.
Oh, we need to create a constructor too. It's probably just gonna be tank, right? And then we also go in here. Woo! Woo! I like the shark. Is that a Katy Perry shark? This is gonna be shit. What is this called? U tank? A tank. A tank? We gotta scope it.
In the public section.
Chat's going off today. What's up, chat?
Inside the constructor, construct our camera and spring arm components using create default subobject. Make sure to use setup attachment to attach these components to something. We'd like our
Oh my Lanta, this is a little bit what did I do here? Chat. Base on. So this is probably a tank. A tank. Chat, you're real for that. Wow, it's so exciting to have more than one person in chat and actually get to say, chat, you're going insane right now. Chat vibes. Hell yeah, we vibing. Straight up vibing. There's more than one person, so I don't have to address by the specific name, you know? It's chat. The general conglomerate. Beast mode. Okay. Plural, no more. That's what's up, baby. That's what's up. We love that. We love that. Capsule comp equals create default sub object. I think we're just literally copying and pasting this here. I think. Therefore, I am. Wait, no, because I already created this in base pawn. So do I need to recreate it? Yeah, I do, because it's a...
To the root component. So use root component in setup attachment. And for the
2
camera,
over
attach
1
it to
equals
the spring
max.
arm. You can refer back to the base
Yep,
pawn class
these emojis
to
are
remind
going
yourself what
nuts.
the code looks like to do these things. Go ahead and pause the video and add these things to the tank class.
How about the
tank.h. Now, first things first, I'd like to have a
one of
public
these?
section and a private section. So the private section will be where we add these two new components. We're going to want a U spring arm component, which will be a
sugar. Oh, that's right there.
pointer, and we can call this spring arm. And we'll also need a
Unreal.
U camera component, and we'll call this camera. That's okay if your names are slightly different. Now,
Camera
right off the
comp.
bat, I'm seeing the IntelliSense errors here, which means I'm going to need to forward declare these. So I'm going to use class with spring arm and class with camera. Forward declare. We need our U property. Let's add the U property macros. And inside the U property macro, we're going to want to have some specifiers. These will be visible anywhere. As we saw that the components need to have visible anywhere for us to be able to adjust their parameters in the details panel. Now, I'm not seeing any immediate need for exposure to the event graph, so I don't think we need blueprint.
Yo, chat's going off today. What's up, chat?
I'm going to leave them out. Now, I'm going to give these a category. And since these are components, I'm going to just stick
I'm
them
really
in
good
components.
at bird sounds. Well, just that one bird. I could do a duck too, actually. I don't know if that's way too loud for you.
Category along with our other components. Now, I'm not exposing these to the event graph, so I don't need our meta allow private access specifier. So this is enough for spring arm. And I'd like to give the
Wait, we don't want meta? Camera does, though. Camera
camera
needs to
component the same U property. So I'm copying it over. So now we have our components. The next thing to do is to construct them in the constructor, which means we need a constructor. Now the constructor will be the same name as the class, so it's a tank, and we need to define this constructor in the CPP file. So let's go to tank.cpp.
They're trying to break in. Get them, birds. Get them.
So there's our function.
We're going after green
Tank
coke.
constructor must be prefixed with our class name and the scope resolution operator. That's these double colons here. That way we're not just creating a new function,
Scope,
but
new scope.
defining our constructor for this class. Now we'd like to construct these components. So let's start with the spring arm. So we're going to say spring arm equals
Yeah, for real, that's what I did wrong. Spring arm. I believe this is what I called it. Oh, we're eating birds now? Oh, you want to see a cat?
subobject.
Kitty
This is
cat.
U spring arm
Hey,
component.
hey, 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 hey,
And for the
hey,
text,
hey, hey.
I'll simply
Cat
call
in my
this
lap.
spring arm.
Cat in my lap.
And for the attachment, we're going to set
She heard the calls. She came running. Create default sub object. Use spring arm. Yeah, the cat controls me actually. It's the cat. Kona. Her name is Kona. She controls my life.
spring arm, setup attachment, passing in root component. Now I was waiting for it. There it is, the IntelliSense error saying pointer to incomplete class type use spring arm component. That's because we need to include the header file since we're creating and using a spring arm component. So here's my Unreal Engine documentation, and if I scroll down, there's my include. So I'm going to copy that.
Weak.
And paste it right here at the top, just under tank.h. Now, just a side note, in general, you're going to keep your class header file include at the top and includes for your components underneath that. So we have our spring arm. It's time to construct the camera. So we're going to say
This
camera
man ain't typing at all.
subobject, u camera component, and in the text macro, I'm going to call this simply camera. And for the camera, I'm going to call setup attachment, passing in spring arm. And of course, I need the camera header file. So here's the Unreal Engine documentation. And here where it says search documentation, I'm going to type u camera component. And here I see u camera component. I'll select that. And here's the documentation for camera component. So I'll copy it.
We need cookies to keep up the support. Sugar Rush is dimming down. Well, just enable cookies then, my friend, on your browser.
Include
Oh, there they are!
here.
Green coat coming in with the cookies.
At the top.
Uh-oh, we got spam coming in from Kick. Overcome washing P. Yo, you trying to grow your stream faster? Viewers, subs, all that. I got something cool. Search the site on googlebotsister.com. Not gonna do that, Overcome washing P. Green Coke, appreciate the cookies. Keep them cookies rolling, baby. Oh, wait, we want to set up attachment to spring arm, please. And I need to include a header.
And now we should be good. Okay, so let's go ahead and compile this. Okay, so I have...
You gotta keep it real. You gotta keep it real. You come spamming in my chat, I'm gonna tell you no. That's about it, though. Why are we building? Build fail, build fail. Found while parsing variable specifiers. Visible anywhere. Is it everywhere?
A successful compile. Let's head back in the editor.
Build. Overcome washing MP. Yeah, I guess that's the name they chose to go with.
And here on pawn tank, of course, we don't see anything because pawn tank is derived from base pawn, and the components we just added, we added to the tank class. So BP pawn tank is not going to get those because it's not derived from the tank class. Now we could go and create a new blueprint based on the tank class, but then we'd have to set up these components all over again, and I don't really feel like going through all that work a second time. There's an easier way. We can reparent this blueprint to the tank class. We do that by going up to class settings. And in the
wait, hold on. Let's come back here. And I want to use spring. No. Where it is?
Inherited some things from the base pawn class.
I need to debug my code. Where are the bugs? I need to find the bugs. Kona, this is your job. You're supposed to be killing all the bugs. It's like visible anywhere. That's right. Oh, duh, I need the meta.
Need for exposure to the event graph, so I don't think we need blueprint read write or blueprint read only. That's okay if you added them. I'm going to leave them out. Now I'm going to give these a category. And since these are components, I'm going to just stick them in our components category along with our other components. Now I'm not exposing these to the event graph, so I don't need our meta allow private access specifier. So this is enough for spring arm. And I'd like to give the camera component...
Yo, I disagree with you. I think that's not enough for our spring arm. Oh, because I have blueprint read on. Duh. Schnikes, Control Z, Control Z. Here we go. There we go. Delete this. Debug. Engaged. This chat is now launchpad. We're going to the stratosphere here. Chat is taking off. Chat is lifting off. We're still failing the build. Because I spelt wrong. I spelled wrong. This should be anywhere. We'll just control S that right now. Bang, bang. GG's in the chat. Oh, chat, type 1. One's in the chat if you're going to the stratosphere. Chat. One's in the chat. One's in the chat if you had breakfast today. One's in the chat. One's in the chat. Visible. I spelled this wrong again. Ones. Oh, we're spamming ones right now. We're spamming. Yo, I can't spell. One's in the chat if you can't spell. Two's in the chat. Ones and twosies. Ones and twosies. All right, this is it. This is build. Yeah. Oh, a 0. We got a 0 in the chat. We're coming back down from the stratosphere. Yeah, we're building. Bugs eliminated. Build about to pass. Oh, come on. What is this, Jimmy John? No breakfast yet. I had some smooth berries, mixed berries for breakfast. I broke my fast. Yeah, it's healthy, but just not enough. I'm starving right now. I need some actual calories in my belly. But I need, maybe I can eat these bugs. Maybe these bugs will spring give me some caloric. This is need a class here. I did. I didn't include the header. LOL. Hey, liquid calories. It's a thing. Liquid breakfast. Fermented berries. That's a good way to put that. Nothing quite like some fermented berries with a side of, I don't know. Why are we still failing? Spring arm component. That's what I have. Oh, no, I don't. Yeah, I do.
Component, the same U property. So I'm copying it over. So now we have our components. The next thing to do is to construct them in the constructor, which means we need a constructor. Now, the constructor will be the same name as the class, so it's a tank, and we need to define this constructor in the CPP file. So let's go to tank.cpp and create a tank. So there's our function body, and the tank constructor must be prefixed.
Chat's popping off, distracting me from the task at hand. Talking about fermented berries, drinking a little vino.
We'd like to construct these components.
Don't hate it though.
With the spring arm.
Distract away.
So say spring arm equals create default subobject, and this will be a U spring arm component. And for the text, I'll simply
this is
call
what
this
I've
spring arm.
this is what I've done
And for
to
the
a
attachment,
T.
we're going to set spring arm passing in root component. Now I was waiting for it. There it is, the IntelliSense error saying pointer to incomplete class type use spring arm component. That's because we need to include the header file.
All right, what is the error saying?
Spring arm component. So here's my Unreal Engine documentation, and if I scroll down, there's
Use
my
of undefined type use spring arm
and
component.
paste it right here at the top, just under tank.h. Now just a sec.
Game framework spring arm component. Oh, yeah. That's because I included the wrong header. How embarrassing. I'm so embarrassed. Game framework slash spring arm component. Control S. We're gonna jump ahead and try to compile here. Compile. I'm so embarrassed. I can't even compile. Oh, and same deal here. Camera, what do we need to include?
You're going to keep your class header file include at the top and includes for your components underneath that. So we have our spring arm. It's time to construct the camera. So we're going to say camera, create default subobject, U camera component, and in the text macro, I'm going to call this simply camera. And for the camera, I'm going to call setup attachment, passing in spring arm. And of course, I need the camera header file. So here's the Unreal Engine documentation. And here where it says search documentation, I'm going to type U camera.
Wait, how do I get to the Unreal documentation? That would be lovely to learn. I probably should know that. Let's see. Unreal documentation. This could be Unreal 5.5, 5.6. Okay, so what's new? No. Release notes? No. Can I just search use spring arm or something? Aha! What's the issue here, huh? I don't like how this is. Whatever. We'll solve this
Component.
today.
And here I see U camera component. I'll select that, and here's the documentation for camera component.
Camera/camera component. Camera. Camera/camera component.h. Control S. Last build, please. Last build. No. Camera undeclared. False. I declared a camera. Cat on my lap. Cat on my lap. Hey, hey, hey. Cat on my lap. Cat on my lap. What you got? What you got? What you got? Go on your 2 legs, Kona. Let's do tricks. Let's do tricks. 2 legs. 2 legs. Kiss. Bah. Sorry, PDA. Gross. This is probably this. Mwah.
So I'll copy its include, paste it right here at the top of our file, and now we should be good. Okay, so let's go ahead and compile this. Okay, so I have a successful compile.
You do. I don't. Game framework slash spring arm component.h. That works. Camera slash camera component.h. That works. EU property. Oh, it's camera comp. Duh. This is it. This is it. This is the one. So far, so good. Oh, my FAO Schwartz. Set up, attach. My goodness, my Guinness. You know, you can tell I'm not very good at coding by the amount of times I've tried to debug this same line. But hey, in order to be good at something, you have to first start out being bad at it. Usually. And look at that. Successfully linked patch. Just like that, baby.
Let's head back in the editor, and here on the pawn tank, of course, we don't see anything, because pawn tank is derived from base pawn, and the components we just added, we added to the tank class. So BP pawn tank is not going to get those because it's not derived from the tank class. Now, we could go and create a new blueprint based on the tank class, but then we'd have to set up these components all over again, and I don't really feel like going through all that work a second time. There's an easier way. We can reparent this blueprint to the tank class. We do that by going up to class settings, and in the details panel with class settings selected, we see class options, and there's this parent class. The dropdown shows that it's set to base pawn, but if we click on it, we can search for tank and choose tank as the base class. And now this blueprint is derived from the tank class. So we see that all of those properties we set with our components, such as the mesh and the capsule size, they're all still there, only now we see a camera. In fact, we have a spring arm and a camera, and if we select the spring arm, now we can see that red line. So this is great. So I could take this spring arm component and change its target arm length if I like. I could set it to something like 600. And I can even change its rotation so that it's angling the camera down at the tank by selecting rotation mode and rotating it up a bit, like so. Now, I'd like to point out that you shouldn't change the camera's location. It might be tempting to select the camera and move it around in the world so that you position it and angle it just right, but this is not the correct way to do it. The correct way is to set the rotation and target arm length of the spring arm component. And the reason is you want that camera attached to the end of the spring arm. The spring arm has lots of different built-in features.
Interesting. Well, the spring arm should be attached to the base mesh. Sure.
Such as shrinking in when the camera hits up against a wall to avoid obstacles blocking the view to the pawn, and other things like that. So you're going to want that camera attached to the end of the spring arm and then adjust the spring arm rather than adjusting the camera's position and rotation. So in this video, we created the tank class, and we derived from base pawn to inherit those qualities from the base pawn class. We added a spring arm component and a camera component and exposed those to the editor using visible only and put them in their own category. So we're getting closer to the finished product step by step, and we'll continue developing this tank in the next lecture. I'll see you
Hell
soon.
yeah. All right. I'm switching over. Save this. We're going to go play some Minecraft.